In this video, I will show you how to find the interval of convergence for a given power series. And to find the interval of convergence means to find all the values of x for which the given power series converges. And to find it, we're going to use the ratio test. So to set up the ratio test, I'm going to write the limit as n goes to infinity of the following ratio. I'm going to take the successor and divide it by its predecessor. So the following expression goes in the numerator, and we're going to divide everything by the nth term. Now, simplifying this ratio as a single fraction will give me the following result. I'm going to have -1 to the power n plus 2 x minus 2 to the power n plus 1 times n times 2 to the n over n plus 1 2 to the power n plus 1 minus 1 to the power n x minus 2 to the power n. Now, combining and reducing, we get the following. So since we have an absolute value, these -1s to powers n are irrelevant. We also have limit as n goes to infinity of n over n plus 1 times 1 over 2 as 2 to the n basically reduces this 2 to the n, and we also have x minus 2 to the n reduced with this x minus 2 to the n, so we just have absolute value of x minus 2. And we can rewrite this with absolute value of, with actually 1/2 of absolute value of x minus 2 outside of the limit. And what's left is the limit of n over n plus 1. And you can see that this limit is actually equals to 1. So the following ratio has to be less than 1 in order for the series to converge, and this creates a compound inequality which we can easily solve. To get the following values for x. So adding 2 to both sides will give me x is between 4 and 0. Now, in order for me to decide whether to include 0 and 4, I have to check whether the series converges at x equals 0 and x equals 4. So let's check this power series at x equals 0. So when x equals 0, we get the following series. And you can see that -2 to the n can be rewritten as -1 to the n times 2 to the n over n times 2 to the n. And 2 to the n can be cancelled, and -1 to the power n plus 1 and to the power n can be combined into this expression, and 2n plus 1 is actually an odd number, and -1 to the odd power is actually -1. So we don't have an alternating series here, we just have a harmonic series which diverges. So this one diverges because it is harmonic, but to be more precise, because it's p series with p equals 1, which is less than or equal to 1. Now the only thing that's left is to check whether the series converges at 4. So replacing x with 4 gives us the following series. So now we have 2 to the power n, and 2 to the power n cancels or reduces, and we have the following series. So this time it is actually an alternating series, and this one converges by the alternating series test. So what we learned is that this power series converges for all x's between 0 and 4, and in addition to those, it also converges when x equals 4. So the interval of convergence is from 0 to 4, including 4 and excluding 0.